welcome back, guys. Today we're extending last week's lesson, which was simplifying square roots. And now we're gonna still simplify square roots, but we're gonna have variables in there. So today's lesson title is Simplifying Square Roots with variables. Okay, so let's just do some kind of quick recall of things we've been dealing with. When I think of square roots, I think of perfect squares. Okay, they're like best friends. Square roots, perfect squares, they're like best friends. So what I mean by perfect squares is if you were to square 1 squared is 1. 2 squared is 4. 3 squared is 9. So 1, 4, and 9 are all perfect square numbers. Okay, now we could keep this list going. We could do 4 squared and 5 squared and all that good stuff. But I'm hoping you kind of remember that already. But today we're talking about variables. So what happens when I take a base with a variable in it, like x, and I square it? Well, this little exponent says you take the base and you multiply it by itself 2 times. So that's x times x. Well, x times x can be represented as x squared, or x to the second power. All right, well, I'm going to change the base a little bit. We're still squaring stuff. Instead of having x and then squaring it, I'm going to take x squared and then square it. Now, you're going to have to go back to power rule here. Power rule says if you have an exponent and you're raising it to another exponent, what do you do with those exponents? Well, you actually multiply them. So x squared raised to the second power ends up being x to the 4th power. All right. Now let's take x to the 3rd power and square it. Think about that, what that would be. Is that x to the 5th or x to the 6th? What do you end up doing with these exponents? And hopefully you said multiply. You end up having x to the 6th power. Okay, let's keep going with this. I want you to take x to the 4th power, square it, x to the 5th power, square it, and x to the 6th power, and then square it. Pause the video and then check your answers. Okay, so x to the 4th power squared ends up being x to the 8th. So we multiply 4 and 2. X to the 5th power squared is x to the 10th. X to the 6th power squared is x to the 12th. Now, why am I having you square all this stuff? Well, just like 1, 4, and 9 are perfect squares. And the reason why I know these are perfect squares is because in order to get them, I had to square something. Okay? Now, these are also perfect squares, though, because in order to get them, you squared something. Okay? So we have this, huge list from last time we did stuff. Perfect square numbers, 1, 4, 9, 16, 25, and it keeps going, right? Well, we also have variables that are perfect squares. So we're going to compile our lists right here and just call this perfect squares. Okay, so obviously we're gonna have some numbers in there, right? So numbers like 1, 4, 9, 16, 25, 36, 49, 64, and we could keep going, right? There's a bunch more numbers. But what we're gonna add to our list are these variables that we just found, our perfect square variables. So x squared is a perfect square. X to the 4th is a perfect square. X to the 6th is a perfect square. X to the 8th, X to the 10th, X to the 12th. And our list does keep going. There's more than this. And hopefully you're noticing something like a pattern here. Power of 2, 4, 6, 8, 10, 12. What would the next one be? 14, 16, 18. Okay? So hopefully you notice that pattern, but I want you to go even deeper than that. What types of numbers are these? 2, 4, 6, 8, 10, 12. Are they even or odd? They are definitely even. Okay? So if you had like x to the 50th power, 50 is an even number, that's also a perfect square. It's a perfect square variable. Okay, so this little thing right here, we're going to box this up. We're going to refer back to this quite a bit. Okay, next little section in your notes, we're going to say finding square roots of perfect squares. Finding square roots of perfect squares. Okay, so we like finding square roots of perfect squares. Reason is we end up with a whole number. So like square root of 9 is 3, square root of 36 is 6. We end up with whole numbers. That's why we like these. Now that's going to also happen with perfect squared variables. Taking the square root of these, we're going to end up with a nice answer. Okay, there's going to be nothing left in the radical is what I'm saying. So let's start off with numbers just to ease into this. If you have the square root of 49, what is that? What's the square root of 49? Hopefully you're saying 7. Now if I asked you to explain why, you do need to know how to explain why. You would say because, one way to think about it is if I take that base of 7 and I square it, I end up with 49. So square roots undo something squared. Okay? They're best friends, but they're also almost like opposites of each other. Okay, well now let's take some square roots of some perfect squared variables. Let's do like x to the 6th. Square root of x to the 6th. Well, I'm going to hold off on writing that, and we're going to go to kind of our reasoning behind it and kind of work ourselves up there. So if I take something and I square it, I end up with this x to the 6th, just like I did here. I took my answer, I squared it, and I got that inside number, which is called the radicand. Okay? So what would I have to square in order to get x to the 6th power? Well, the base is definitely x, but to what power? What goes there? 1, 2, 3, 4. Hopefully you said 3. 3 times 2 is 6. Okay? So the square root of x to the 6th is x cubed. So I want you to try this one. Square root of x to the 14th. Maybe you know it. Maybe you need to do this first. That's fine. I want you to think of what you would have to square in order to get x to the 14th power. Okay, so what little number would go here? Something times 2 is 14, and that something is 7. So the square root of x to the 14th is x to the 7th. Okay, and we'll do one last one. X to the 24th power. Okay, I'm hoping you just notice that if I take a square root of a variable to some power, really what you're doing is you're kind of cutting it in half, and that's because you're timesing it by 2 over here. Okay, so this would be x to the 12th. If you had x to the 100th power, square root of x to the 100th power, you'd end up with x to the 50th because it's just half of 100. Okay, that's cool and all, but now let's do some actual practice with this. So we're gonna just stick with perfect squares for now. So I'm gonna take a perfect square number like 100. It's not written in our list up here, but that's because we can't write an infinite amount of numbers. But 100 is definitely a perfect square. X to the 10th is a perfect square, and y squared is a perfect square. Okay, so we're gonna go ahead and simplify this down. Now, I can break this apart into several radicals. We learned that last week. So I can break this apart into the square root of 100 times the square root of x to the 10th times the square root of y squared. And then I'm going to simplify anything that's a root of a perfect square. So what is the square root of 100? It's 10. Square root of x to the 10th, hopefully you remembered our practice right here, that would be x to the 5th. Okay, and you can also check it up here, x to the 5th time, or to the 2nd power, x to the 10th. And then what's the square root of y squared? It'd be y to the 1st power. Do you need that little exponent of 1? No, not really. So when you write your final answer, you can kind of shove all this together since it's multiplying, and you write your final answer as 10 x to the 5th y. Okay, let's try another one. Pause if I'm ever going too fast for you. We're going to stick a negative out front of the radical. And inside the radical, we have a lot of stuff here. We got 36. We have a to the 12th power, b to the 4th power, and c to the 22nd power. Okay. All right, so anything that's out front is just multiplying by whatever we get. So I'm just gonna drop down that negative. I'm gonna break apart the radicals because it kind of helps me see it a little bit better. So this is the square root of 36 times the square root of a squared times the square root of b to the 4th times the square root of c to the 22nd. Next, I'm going to simplify any of the perfect squares that I can, and guess what? All of these are perfect square. This is a perfect square number. Square root of 36 is 6. So I just drop that negative, and that's now negative 6. Square root of a to the 12th. Well, half of 12 is 6, so that'd be a to the 6th. Square root of b to the 4th would be b to the 2nd. And square root of c to the 22nd. You just have to think about what, 22 divided by 2 is basically. C to the 11th. All of that I can kind of shove together in one final answer. So my final answer would look like negative 6 a to the 6th b squared c to the 11th. Okay. So hopefully you're thinking, all right, that's pretty easy, I can handle that. But what happens when our variable is not raised to an even power? What if we had it to the 5th power, or the 7th power, or the 21st power? So what do we do then? And that's what we're going to talk about next. Oops, sorry. Okay, so let's ask ourselves that question. Let's just write it down so we have it in our notes. But how would you simplify the square root, and let's do x to the 5th power. How would you simplify square root of x to the 5th? And notice x to the 5th is not listed in our perfect squares. But our answer to this is just like what we did last week, where you have to, I'm gonna flip back, you have to find the largest perfect square that can kind of be divided into x to the 5th, okay? So here's how I'm gonna show you how to do this. Well, x to the 5th, so square root of x to the 5th, is the same thing as, And we're going to kind of break apart this x to the 5th. It's the same thing as x to the 4th times x. And if you don't believe me, let's just go over stuff we learned last chapter. X is the same thing as x to the 1st power. And we know product rule for exponent says when you're multiplying and bases are the same, you add the exponents, right? 4 plus 1 is 5. So this is the same thing as x to the 5th. So I haven't done anything. I'm just changing its form. But what this allows me to do is now I can break apart these two radicals into square root of x to the 4th times the square root of x. Okay, that's a property of radicals. I can split apart this product into the square root of each one, but they have to be multiplying still. Okay, now what's the point of this? Well, oh my gosh, that's a perfect square. X to the 4th is a perfect square. I know that because it's raised to an even exponent. So I can go ahead and simplify square root of x to the 4th. Square root of x to the 4th is x squared. Now it's timesing by this radical x though. This cannot be broken down further. So what did we do with things in our last little lesson last week? What did we do with things that couldn't be broken down further? Well, we just kept it in the radical. So we're just gonna keep this in the radical, and that's our final answer. Okay, so that's the simplified version of this. Let's try another one. We're gonna have an 8 out front. Remember that 8 is just multiplying by all this stuff. And inside, let's do x cubed and y to the 7th. Okay, so that 8, I'm just bringing it along. And now I'm gonna start breaking apart this expression right here, x cubed, square root of x cubed. Square root of x cubed is the same thing as the square root of x squared times the square root of x. Okay, if you were to multiply that together, you'd get the square root of x cubed. Now we're gonna have to do the same thing with y to the 7th because that's not a perfect square. But I can break it apart into y to the 6th power times y. So square root of y to the 6th times square root of y. Once again, the reason why is if I were to multiply these, I would get square root of y to the 7th power because you add the exponents. Now we get to just simplify a whole bunch. Now this 8 is not going anywhere. We're just bringing it along. Square root of x squared, that's a perfect square. The square root of x squared is x. This is not a perfect square, so I'm going to leave it alone for a second. But the square root of y to the 6th, that's a perfect square inside, so I can actually take the root of that pretty easily. Square root of y to the 6th is y to the 3rd. And square root of y, I can't simplify that down further. So I took care of 8, so that's done. I took care of these two perfect squares, and what I'm left with is the square root of x times the square root of y. Well, we can actually shove that together underneath the radical as x, y. And that's our final answer. Okay, so now what we're gonna do, guys, is we're just gonna practice 4 more of these. If you kind of feel like you're understanding this, totally fine to just kind of fast forward through me talking, and you can kind of try it on your own, okay? Okay, so on number 1 down here, we're gonna have a negative outside the radical, and inside the radical we have 9x y to the 11th. Okay, so we're gonna kind of break this apart. This is what I do. I'm gonna drop down this negative. I'm gonna deal with the number part first, so that's square root of 9 times the square root of x. What's the exponent on x? Just a 1. Times the square root of, now I need to break this down. 11 is not a perfect square, it's not an even number. So I'm gonna break that down into y to the 10th times the square root of y. So I broke that down. split that apart. Now I'm going to simplify any of the perfect squares. Well, cool for us, 9 is a perfect square. So what's the square root of 9? Square root of 9 is 3. But we do need to drop down that negative in front of it. Square root of x, well, x isn't a perfect square. I'm going to skip that for now. Y to the 10th is a perfect square variable. So the square root of y to the 10th is y to the 5th. And then I'm left with radical x times radical y. Now our final answer, we're going to kind of shove things together. So the numbers out front, I'm going to mash those into negative 3y to the 5th. And then these two things that are both taking the square root of them, I can just multiply it as x and y. X times y is just xy. So negative 3y to the 5th times the square root of x times y. Okay. This is a good one for you to actually pause the video and try it without my help. So underneath the radical, you have 12 x to the 8th, y to the 3rd. Okay, now this is one where 12 is actually not a perfect square. 9, it was really easy, we just made it into 3. But the square root of 12, 12 is not a perfect square number. So I'm gonna have to break that apart. Square root of 4 fits into 12, and 4 times 3 is 12. So I'm gonna break that apart into square root of 4 times square root of 3. Next, do I need to break apart this x to the 8th? Well, 8 is an even power, so that's already a perfect square, so I'm just going to leave it. Y to the 3rd power, 3 is an odd number, so I'm going to have to break that apart into y squared times y. So square root of y squared, square root of y. Okay. 4 is a perfect square, x to the 8th is a perfect square, and y squared is a perfect square. So I'm going to simplify those first and kind of put them out front. Square root of 4 is 2. The square root of x to the 8th is x to the 4th. Square root of y squared is just y. And then these things that can't be simplified further, they get put together under the radical, 3y. Final answer, 2x to the 4th y times the square root of 3y. 2 more problems. I'm going to write them down and then give you a second to just kind of work on them. So number 3, you're going to have a negative 3 out front. Under the radical, you have 100 n to the 10th power, m to the 7th power. Number 4, you have a 5x outside, and inside the radical you have 18 x to the 20th, y to the 5th. Great time for you to pause the video, honestly try it on your own, and then hit play again. Okay, over here I'm just gonna drop down this negative 3. I'm gonna split these apart. Square root of 100, that's a perfect square. That's good news for us. I don't have to break that down any further. N to the 10th power, that's gonna be a perfect square. Awesome. M to the 7th power, that's not a perfect square, so I'm gonna have to break that into 2 radicals. So we'll do m to the 6th times m to the 1st, or just m, okay? All right, next I'm gonna kind of look through, see what my perfect squares are. So this negative 3, I'm just gonna drop it down. Square root of 100 is 10. Square root of n to the 10th power is n to the 5th power. Square root of m to the 6th is m to the 3rd. And I can't break down the square root of m, so that actually gets left inside the radical. Okay, lastly, we're going to kind of simplify this down, multiply what we can. Negative 3 times 10 is negative 30. N to the 5th m cubed times the square root of m. Final answer. Okay, this last one. This is one where it's like if you can do this, you can do anything. Okay? So this 5x, which is 5 times x technically, I'm just going to drop it down. Oops. Okay. Radical 18, square root of 18. 18 is not a perfect square, so I need to break it apart. So what's the perfect square number that divides into 18? Well, it's 9. So I'm going to break that down into the square root of 9 times the square root of 2. X to the 20th. 20 is an even number, so I'm happy with that. We can leave it. It's a perfect square number. Y to the 5th. 5 is odd. We got to break that apart into 2 radicals. We'll do y to the 4th and y. Remember that, just multiplies up back to y to the 5th. So we've just changed the format, and now we get to kind of simplify what we can. So I'm just going to drop down this 5x, and by the way, that is 5 times x. Square root of 9 is 3. Square root of 2, that's not a perfect square. Square root of x to the 20th is x to the 10th. Square root of y to the 4th is y squared. And I can't really simplify down the square root of y. So now I'm going to bring down the leftovers. Radical 2 times radical y. Okay, so we're going to multiply by what we can here. You really got to pay attention here. So I have all these numbers out front. 5 and 3. I can multiply that up. That makes 15. Okay, so I got that and that. And now I have 2 things that have a base of x. I can put those together. I can multiply those up. This is x to the 1st power times x to the 10th power. Bases are the same. When you're multiplying, that means you add. Okay, so that's x to the 11th power. So I got those taken care of. Y squared. And then we're going to have whatever's left in the radical. So what's left in the radical? 2 times y, which we write as 2y. So that would be your final answer. So watch this as many times as you need to get it down. All it really takes is practice, guys, and some number sense with perfect squares. Okay? Good luck. Thanks for watching. See ya.